Hey guys, it's Wade here. I'm trying two tests at once. So normally when we test something out, we're supposed to limit our variables, but I've doubled my variables. I'm gonna try out my new pin holder on my plasma cutter. As you can see, I've got everything set up and I'm gonna try this out. I'm also trying out this video camera here that I got as a present years ago. I've tried it before and it wasn't great quality, so I'm trying to tweak it and see if I can get some good quality out of it. So I may revert back to my video camera just to capture this footage here. So I've got everything set up on Crossfire. Again, I'm going to try this out. This is the first time, so this is a dry run, or a first time run, I guess you could say. It also might be a little slow. This is 20 inches per minute. But I didn't want to go too fast. I also tried to make this loose. Sorry, I tried to make this loose so it would drop down on its own. In other words, the gravity of the pin. But in general, you can see it's doing fine. I'll probably rerun it again just so I get that top side. All I'm doing is I'm going to cut this out and then put it in place to make sure that the metal, as far as the aluminum for the heat shields on the wing roots, which these are the aft 2/3 of the wing root heat shields. So I'm just going to make sure that this gives the same coverage as my templates. Match them up to my templates and then also do a final dry run on the wing roots. Okay, I'm going to do one more dry run to get that one corner with the pin right here. Okay, so this is the right side. Probably should remove that. So this is at 30 inches per minute, just a hair faster. I'll probably start doing this at about 40 to 60. I'll keep upping it more and more. Alright, so the test is good. I'm very happy with this. I'll cut these out. I decided to resume my testing of this camera right here by going ahead and cutting these guys out of this 20,000 6061-0 aluminum. I have to tell you, this aluminum is so thin, it's like peeling peel ply off of aluminum foil. It's got a lot of creases in there. And I actually put a board on there to help. This stuff is thin. So I'm going to go ahead and cut the left side first. That's exactly as I put it into CAD. The right side, I took a little bit off around the border, around 18 thousandths all the way around, just to get rid of the thickness of the line. It was just a hair proud. So that should be fine. And then of course, if I need to, I can hit it with the edges with the file. Alright, let's fire this thing off. I didn't get a cut all the way through just because this stuff is so thin. It's hard to cut. I'm just going to go ahead and do it again. It's not tearing it up as far as the heat signature around the edge. So we'll do it one more time. Here we go. Okay, so that was the left side. Got a little bit of curling, I guess, probably from the heat, just the spring back, but I think it's a pretty good cut. Anything that is not cut through, I'll just go ahead and hit it with a Dremel. So I wasn't sure if it cut all the way through, but it did the second time around, so that worked. So there's the heat shield for the left side. And again, this is just the aft 2/3. I'm not going to be using this thinner 6061 aluminum for the forward third. It's going to be either the titanium 20 thousandths, which will be stronger than this stuff, of course, or it'll either be the 32 thousandths 6061, or possibly I might try stainless, and I think it's either 16 thou or maybe 20 thou. So I'll play with that, but it needs to be a little bit stronger than this. Okay, so I've got this set up for the right side. At least I hopefully do, because I don't have a lot of nice 20 thousandths aluminum left. I don't know if you can see, there's a number of little divots and bends just from the handling over the years, and taking that tape off of both sides. Okay, I got an error again because it's so thin. We're going to try this again. Okay, I post-processed this again. I changed a couple small parameters, partly based off of the warning that I got. So we'll try this again, see if it cuts any better. Nope. Okay, I thought this might be a little bit camera shy, so I tweaked a couple more parameters and then tried it again. It made it all the way around. I think one more cut and it'll cut it out. So it'll cut it out as far as cutting out the shenanigans and actually cutting out this piece. All right, we're going to try it one more time. All right, I think we got it. Finally, success. And then see what we got. Yep. Okay. So here's the right side. And I think I was able to get it through where all the dents and stuff were. So I think we've got two actually good pieces. So I wasn't sure if I was going to engine turn these heat shields or not. And then one issue that kind of cropped up that I wasn't expecting, I wiped these off quickly when I plasma cut them last night. And then this morning, as I was cleaning them up, I hit them first with acetone and it cleaned them up in general okay. And then, especially on the left side, there's just marks on there that I guess if I hit it with aluminum polish, they would clean up and that would be fine. I don't have any aluminum polish. I was leaning towards engine turning them anyway. One of the issues is that, again, this material at 20 thousandths is so thin that I didn't want the pressure of the disc coming down to deform this, or because these can get a little bit hot. And so I just grabbed a scrap and I didn't even clean it. So this is right off from one of the sides of when I plasma cut these heat shields out. And again, I didn't clean this, and then I just hit it really quickly when I mounted this. I'm sure if I cleaned it up a little bit more, it would look even better. It didn't in any way, shape, or form, especially on the narrower end down here. I was a little concerned with the pressure coming down, that it might bend it up or something. It did fine all the way down, just like on the 32 thousandths. So I'm going to go ahead and engine turn these heat shields, and I'm not going to engine turn the other ones. And when I mount these here in a little bit, I'll show you the difference. These are on the very edge of the wing root. The other ones in front of these that are inset about 1.5 inches, and that's what these little round grooves are for is because I'm going to bend this after I engine turn it. I'll bend these tabs, which are 1.5 inches, in 90 degrees, and then they'll marry up with a dog leg for the front, which is inset 1.5 inches, because that's going to go forward and hit right at the edge of the front, very front corner of the wing on the vertical corner. And there's a gap there between the wing and the center section spar that needs to be covered or filled in to keep the hot gas pressure from the engine compartment from running down the center section spar and escaping out along the center section spar. Not only do you not want that heat going out along that bare glass that's not covered up along the center section spar, but you're also losing cooling air, and then you're allowing hot air to go down, and you just don't want it. So a few different reasons for covering that up. Thus this bend right here. Also, this side's still dirty, but it took me about maybe 5 minutes a piece, just hitting the edge with a Dremel tool to get the dross off, minimal dross. The cuts on these are really good. There's like hardly any heat affected zone visible, and so I'm really happy with the numbers so far that I've got off the matrix that I built for all the feeds and speeds, if you will, for the plasma cutter and the plasma cutting table. All right, I'm gonna get to this. To get this started, and to not belabor this video, I went ahead and started this first row. This is on the left. Now the left heat shield covers about 2/3 of the wing root from the very aft end forward, and then the right covers about 3/4, but just as a little side note. But here's the beginning, and then I'm going to go ahead and do the next row. Looking good. I'm going to mark up and do the next row. There's row number 3. I'm not showing you the markups because I have a whole nother video I did on engine turning, and I'm not going to go through and explain all of it. I'll leave that video link in the description. I thought I had one more mark out here, but I guess I don't. Last thing you want to do is get to the very end and then screw up the pattern. I mean, this thing's going to be in the engine compartment. I'm just sprucing it up, making it look not so ugly. Like I said in my last video, if you look closely at any individual circle, you can definitely see lines and all that, but just the total effect that you see, that prismatic effect, it just really spiffies it up. So again, this is the left side. I'll clean this up, and then I'm going to bend this, and obviously I'm going to do the same thing on the right side. This is definitely looking good, and I'm pressing forward. Okay, sorry about my arm being in the way. I tried to get these cameras set up as best as I could without blocking the shots. We're going to continue on with the right side. I'm going to do the same thing. I'm going to start from the forward top side and then move down just like I did on the other side. There's a creature in here trying to get rid of them. There's the first row. I've got probably the longest run, as you can see, goes all the way to the end here. Again, gonna mark it up. Line number 4. Need to mark this last one. Okay, one more row to go. are officially done with the engine turning. And again, I mean, it's not perfect, but I'll always go back to my statement of that prismatic effect overall just really makes it look cool. And it doesn't really take that much extra time, probably 45 minutes for each piece. Here's the left side. Okay, so I'm going to get to mounting these things. I wanted to show you just really quickly that I bent the front tabs 90 degrees and I had to trim them up a little bit, both on the top and the bottom on each one, a lot less on the right side, but nonetheless I still had to trim a little bit away, mainly because of the thickness of the L-shaped tabs that I glassed in that are going to hold these in place. And then I had to make this little groove, little notch right here because of a cam lock. I can't get this in and around the cam lock unless I take the oil cooler out by notching this right here and then bringing this down just a hair at an angle. I'm able to squeeze this in with the oil cooler in place on the left side. I bent them on the metal brake. Took me probably about 30 seconds, 45 seconds to line them up with the bend line, and then it probably took me 10 seconds to bend each one. So 20,060/61-0, so it's pretty soft. Oh, speaking of which, now I still haven't cleaned up the back sides, but I don't know if you can see this. There you go, from the heat and the pressure is in here. So it actually did make some indentations. Kind of interesting, but I'm sure it'll work nonetheless. All right, I'm going to get to installing these. Just wanted to show you that. Okay, sports fans, as I show you the installed and completed left wing root aft heat shield, which I of course have been working on. I'll note these are not the final screws, these are just temporary, but I've added another variable to this whole entire adventure, and that is the camera I'm shooting this on, which is the DJI Osmo Action 3. It's essentially a GoPro equivalent, some say better. I'll let the people out there be the judge, but I'm shooting this in 2.7K on the left side. I'm going to try it on 4K just to see if there's a difference. As you can see, up here, this is the configuration I was talking about throughout the construction of this heat shield, which we have this protrusion by way of this oil cooler. That drives us to need to inset the forward heat shield 1.5 inches inboard. You can see the edge of the corner of the wing where there's a gap I'm putting my fingers into. That gap needs to be covered, and that's the gap that goes back down along the center section spar. So the forward heat shield on the left side, because of that edge there and because of the oil cooler, will be inset 1.5 inches. Welcome to the right side. Here we have the completed wing root aft heat shield, also with the temporary screws in place. At the front, this fancy gold box is the autopilot roll servo. That is what's keeping this from just going straight in. I have about 3/4 of the aft wing root here covered up by this heat shield. And then if you can see back in here, that's the wing edge where I'm going to have the inset heat shield. There is just enough room if I go 1.5 inches in to get around this roll servo. So I just wanted to show you this. Wanted to show you the adventure of making these heat shields. Okay, a quick postscript, guys. During a discussion I was having with Steve Beer last year about installing and making the carbon fiber inner baffles, we discussed how he made his wing root heat shields. He actually wrote an article up about it. And that's where I got this idea. I need to give credit to Steve Beert. I think Mike Beasley installed the Steve Beert style of wing root heat shields. Ugh. And again, so I need to give credit to Steve Beert. This is the original, and then this is his write-up. So thanks for watching, and cheers.